Hello students, hello world, Dr. K here. I want to come at you with a video about combinations and permutations and calculations. How many different flavors of ice cream can we fit in a cup or cone? It's just a mathematical topic that I really like, and I want to explain to you the formulas and how we count. Okay, so let's start with a very simple example, okay? We've got 5 flavors of ice cream. See how these are the 5 different colors, 5 different flavors of ice cream. So you can think of them, whatever, strawberry, pistachio, chocolate, lemon, vanilla, whatever they are. They're just 5 of them, okay? And you can get them, you can get 3 flavors, 3 flavors. You can get them in a cup, like for example, this is how you got these 3 in a cup, where the order doesn't matter. The order doesn't matter. Or you can get them in a cone. In a cone, see, that's a cone. That's my way of making a cone. In a cone, the order does matter. So like, for example, the chocolate is at the bottom, the vanilla is in the middle, the, what do we say, banana is up top, whatever they are. And that would be that would count differently from, let's say, this, where now the order is different, okay? So there are 2 ways that you can have your 3 scoops of ice cream. You could have them in a cup, where the order of scooping does not matter, or you can get them in a cone where the order of scooping does matter. You know, remember at an ice cream parlor, in an ice cream shop, you get the scoops, you get the first scoop, you get the second scoop, and then you get the third scoop. So the order does matter, okay? So how many different ways can we get 3 different scoops in a cup or in a cone when you have 5 total scoops to pick from, okay? Cup versus cone. Order doesn't matter in a cup, order matters in a cone. But before we start, there's another complication we can think of. Am I allowed to have repetitions? For example, can I have a cup of 3 chocolates? Is that allowed or is that not allowed? That's another thing that would make things more complicated. And am I allowed to have, for example, 2 chocolates and a strawberry? Is that allowed or is that not allowed? So we really have to decide whether we are having our 3 scoops of ice cream in a cup or in a cone. And we really have to decide whether we're going to allow replacements, meaning allow duplicates, allow repetitions, or not allow repetitions. Okay? So that now I have set the ground rules of all the different possibilities. And now let's do some math. Let's first organize our thoughts. Let's create a table. And it's going to be a 2 by 2 table. Very simple, right? We just have to organize our thought. Big bird's view. And let's kind of first say that we want n is equal to 5. That's the number of scoops. N is equal to 5. That's the number of flavor. I'm sorry. N is equal to 5. Number of available flavors. And R equal to 3. That's the number of scoops. So R is 3, number of scoops. N is 5, number of total flavors. Now, let's say that this here represents a cup. This here represents a cone. And let's say that when we are getting our 3 scoops in a cup, the order doesn't matter. Doesn't matter. And when we get our 3 scoops in a cone, we get a first scoop, a second scoop, a third scoop, and then the order does matter. The order does matter. When I was a kid, it was a big deal. Trust me, the order does matter. I had these long conversations with my mother and father. Okay, now in a cup, we call it combinations. Combinations. In a cone, we call it permutations. Permutations. Okay, bear with me. Now, we're not done yet. Remember, I told you about repeats allowed or repeats not allowed. Let's say that here we say that repeats not allowed. So no repeats, which means that the parlor itself is not replacing. So this is without replacement. WO, without replacement. No repeats. Replacement. And then this is yes repeats, meaning you're allowed to repeat. If you have a favorite, you really love chocolate, you're allowed to have repeat scoops of chocolate, for example, or any other of the 5 flavors. And this is with W/replacement, with replacement. The parlor does replace. They give you a scoop, they replace it. So they don't run out. Replacement. Okay, so now we set up the ground rule. We have 4 different possibilities, right? We have 4 different possibilities. Now, let's just have some common sense. Let's say, which one do you think will give us the most restrictive, the least number of total possibilities? In a cup or in a cone? Without repeats or with repeats? The number that we think out of these 4 numbers, the number that is going to be the smallest possible. We really think, if we think about it, in a cup, the order doesn't matter, and you're not allowed to repeat. So we think that that's going to be the smallest number. We think that this is going to be the smallest number. And now, going this way, we think that in a cone where the order does matter, and you're allowed to repeat, we think that that's going to be the biggest number. That's our gut feeling. And now, in between, we think that these 2 numbers, in a cone with no repeats, or in a cup with repeats, we think that these numbers are going to be in between. So now let's try the first case where we have a cup. We are getting the scoops in a cup, and we know that the order doesn't matter. Order doesn't matter. And we say that these are combinations. These are combinations. And also we're going to say that there's no repeats. No repeats. So you can't have the same scoop over and over. Okay, and let's say that the choices are, the allowed scoops are A, B, C, D, and E. Let's try to list all possible combinations. First one, straightforward, A, B, C. Okay, I like that. We can also do A, B, D, and A, B, E. Now we're done with A, B up front. Okay, what else can we do? Let's start with A, C, D, and A, C, E. Okay, we got that. Now we're done with A and C. Let's do A and D. A, D, E. That's one flavor. Now we're done with A being up front, listing it here. So let's start with B, B, C, D, B, C, E. And also let's not forget B, D, E. B, D, E. And finally the last one, C, D, E. And if you think about it, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possibilities. 10 possibilities. So in this case here, this is the case that we were talking about. This is the case that we were talking about. Let's make sure it zooms. This is the case that we were talking about. There were 10 possibilities. Now mathematically, the formula for this, I want to show you common sense before the formula. I want to show you common sense, and then the formulas I'll give to you later. This, we say in math, now that I've showed you common sense, we say it's combination out of n, choose r, which is out of 5, choose 3, and we write this formula as a ratio n factorial. Factorial, remember we covered that in many videos before. Factorial of a number is just the number times number minus 1, number minus 2, all the way until we get to 1. N minus r factorial, and also r factorial. So if we do the math here, this is no more than 5 factorial divided by 5 minus 3, so that's 2 factorial, 3 factorial. Well, 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. So this 3 factorial can cancel with this 5 factorial, leaving us with 4 times 5. 4 times 5 is 20 divided by 2, and that is where 10 comes from. Okay, so that really is the first case. In a cup, the order doesn't matter. We're doing combinations. No repeats allowed. You have 10 possibilities. And that is really the smallest number. That's the most restrictive. If I was an ice cream parlor, this would be the most restrictive. As a child, you would probably be unhappy with this. Even though you're getting 3 scoops of ice cream, you're not getting it in a cone, you're getting it in a cup, and you're not getting repeats. So maybe one of these flavors, 5 flavors you don't like, so you're not getting repeat. Maybe you can't get like 3 chocolates. Okay, let's go to the next one. Let's go with in a cone, the next logical one, in a cone, but now the order matters. So let's say, for example, that I had these 3. Let's say vanilla, chocolate, strawberry. So let's calculate. So now this possibility, we are in a cone. The order matters. The order matters because let's say you're going to eat the scoops. You know, you're going to, if you have them, if you have the 3 scoops in a cone, which one you eat first? You eat the top one first, right? You eat the 3rd scoop first, then you eat the 2nd scoop, then you eat the 1st scoop. So how they are given to you on your cone, the order does matter. And we are saying here that, again, no repeats. So there is a restriction here, no repeats, meaning it's without replacement. It's almost like the parlor only had 1 scoop of each one of those 5 kinds, and you're only allowed 3 of them, but you get to play with the order. Well, remember what we said here earlier, that in a cup we had 10. So for example, let's say the possibility was A, B, and C. Those were the 3 flavors. Well, guess what? There are 6 different ways that we could organize or permute these 3 flavors. So let's say one way it would be A, B, C, as it is, A, B, C. The other would be A, C, B, right? Now we're done with A up top. Let's put B, and then B, A, C, B, C, B, C, A. Now we put C up front, C, A, B, and then C, B, A. So if we think about it, every one of those 10 outcomes, every one of those 10 combinations, which we have 10 of them, every one of these diverges into 6 possible options. 1, 2, 3, 4, 5, 6. So it makes sense that the number of possibilities, the number of permutations will be 10 times 6. 10 times 6 is equal to 60. And again, common sense tells us that this number here is going to be equal to 60. And the formula is we write a P out of N, permute R. This is equal to 5 out of 5 permute 3. This is, again, just N factorial divided by N minus R factorial. So this is 5 factorial divided by 5 minus 3 factorial. And this is This is really just 5 factorial, so 5 times 4 times 3 times 2 times 1 divided by 2 factorial, so 2 times 1, the 1 and the 2, the 1 and the 2 cancel, so 5 times 4 times 3. 5 times 4 is 20, 20 times 3, and that's where 60 comes from. See that? That's where 60 comes from. So far so good. We're halfway done. We're halfway done. Now, before we get to this case, where you are in a cup and you're allowing repeats, which is the most difficult one to explain, I'll leave it to the end. Let's go with this one here, the one where you have a cone and you're allowed to repeat. So if you think about it, it's actually not difficult to figure out. We know the number is going to be really big. So we think about it. You are the child, you are in front of the ice cream parlor, you need to get your first scoop, and guess what? There are 5 options. Let's say you get one of these 5 options. It gets repeated, so repetitions allowed, and now you can have, for the second scoop, you also have 5 options. Whichever you get, it gets replenished. And then you also have 5 options. So really, if you think about it, this is just 5 times 5 times 5. So 5 to the power 3, which is really n to the power r, which is 5 to the power 3. So it's 5 times 5 times 5, 5 times 5 times 5, which is really 125. And as you thought, see, it's way bigger than 60. It's way bigger than 10. We already predicted that that's going to be the biggest number. That's the maximum freedom. Maximum freedom. Because you get your ice cream in a cone, so the order matters. And also you get repetitions allowed out of the 5 flavors. Okay, so 10, 60, 125. This here is the last one. So let's think about it. We know it's going to be more than 10. We know it's going to be less than 125. That's our gut feeling. It might be close to 60. Maybe it's less than 60. Maybe it's more than 60. But how do we think about it? Well, let's visualize it first. We are getting the ice cream in a cup. The order doesn't matter. But then we are allowed repeats. So the way to think about it is, the way to model it, remember, let's write it down. We are getting the ice cream in a cup. So the order doesn't matter. Order doesn't matter. But we are allowing repeats. We are saying yes for repeats. So it's a special type of combination. Okay. Well, the way to think about it, is to really think of, we are getting 3 scoops. So let's say scoop, scoop, and scoop. See, I wrote the word scoop 3 times. We're getting 3 scoops. 1 scoop, 2 scoops, 3 scoops. And to represent the 5 flavors, I want you to think of 4 bars. 1, 2, 3, 4 bars. And once I draw 4 bars, you can calculate, you can see that this would represent flavor A, represent flavor B, represent flavor C, flavor D, and flavor E. By drawing 4 bars, I've created 5 spaces. So it's really a matter of, where do I put the 4 bars with these 3 scoops? So for example, I can put 1 here, I can put 1 here, and another 1 here. So 1, 2, 3, and let's say 4. Let's say this here. I know it sounds complicated, but let's think about it. What does this represent? This here represents A. This here represents flavor B. In between here represents flavor C. I'm sorry, flavor C. Yeah, what am I writing? Why did I write B? Flavor C, flavor D, and flavor E. Now let's think about it. What is this in a cup? 0 scoops of flavor A, 1 scoop of flavor B, 0 scoops of flavor C, 2 scoops of flavor D, and no scoop of flavor E. Does that make sense? Let's try it again. Let's try it again. Because I really want you to make sure that you get this. This is a very interesting concept. Again, remember, we are getting, there are N is equal to 5, R is equal to 3. There are 5 flavors, right? 5 possible flavors. And we are getting 3 scoops. 3 scoops. But we're allowed to repeat. The order doesn't matter, and we're allowed to repeat, right? I write scoop, scoop, scoop. Those are my 3 scoops. And I need to draw 4 lines, 4 bars. 4 bars to represent the 5 flavors. So where do you want them? Okay. Do you want them here? Do you want them here? And you want them here? Let's say that is the case. Well, what does that give me? This is the A flavor. This is the B flavor. This is the C flavor, D flavor, and E flavor. So in this case, I got 1 scoop of A, 1 scoop of B, 1 scoop of C. The order doesn't matter. 1 scoop of A, 1 scoop of B, 1 scoop of C. The order doesn't matter, and that's the possibility. So now you say, oh, but Dr. K, I mean, I get it. I understand this visualization, but how do I get the formula? What is the formula for this? So what we have here is we are arranging n minus 1. We are arranging n minus 1 plus r items. We are arranging n minus 1 because n is 5, n minus 1 is 4, so 4 bars and 3 scoops, and the order doesn't matter. So it's really the same thing as we write n, the formula is n minus 1 plus r, the whole thing, factorial, divided by n minus 1 factorial and r factorial. And I know it sounds complicated, but let's think about that. Remember, n is 5 and r is 3. And n minus 1 is equal to 4, right? 5 flavors of ice cream, 3 scoops. So let's plug them in. Let's see. Let's try that. N minus 1, so that's 4. So 4 plus 3 factorial. N minus 1, that is 4 factorial. And r factorial, that's 3 factorial. So let's see, that's 7 factorial divided by 4 factorial and 3 factorial. Well, guess what? 7 factorial is just 7 times 6 times 5 times 4 factorial. And here we divide by 4 factorial and 3 factorial. 4 factorial cancels top and bottom. And 3 factorial, well, that's just equal to 6. The 6 can also, this is equal to 6. The 6 cancels with the 6. And we are left with just 7 times 5, which is equal to 35. So there are 35 different ways. So let's go back to our big summary, right? Let's go back to our big summary. And we said that here, this came up with 35 different possibilities. So like we said, it's between 10 and 125. It actually turns out to be more restrictive than, more restrictive, so less possibilities than 60. And remember, the formula was n minus 1 plus r, the whole thing, factorial, divided by n minus 1 factorial and r factorial. And when we plugged it in, it came up to be 7 factorial over 4 factorial and 3 factorial. And that it worked itself out to 35. So now we see we can get, just to wrap up, now we see we have 5 flavors of ice cream to pick from. We have 3, we're allowed 3 scoops, and you can get them in a cup, or you can get them in a cone, and you can see, you understand the difference between a cup, and a cone. In a cup, the order doesn't matter. We call that combinations. In a cone, the order matters. We call that permutations. And to complicate things further, you can make a difference. You can distinguish between repeats allowed and repeats not allowed, which means with replacement or without replacement. Does the ice cream parlor replace the scoop that they give you every time before they give you another scoop? And you can see that we have the whole space is 4 different possibilities, 4 different cases. We have the case that's most restrictive is when you get the ice cream in a cup and there are no repeats allowed. That's the most restrictive, only 10 possibilities, And then you have the most freedom when you get your ice cream in a cone and you're allowed to repeat. So somebody can say, well, I really love chocolate, I'll have 3 chocolates. And I really care about the order. So many different ways. Again, math is beautiful. Combinations, combinations and permutations is one of the most important topics in math. It applies everywhere in biology, in finance, in cryptography, in Bitcoin, in so many things. So really, it's beautiful. It's a beautiful concept. And it's nice to do it with small little math manipulatives and really by hand, nothing fancy. I love you. Do math, do puzzles, and really appreciate being alive and being able to learn. Thank you.